Hi Harshitha, am I audible?
Yes, sir, you're audible.
How are you?
I'm fine, sir. How are you?
I'm good, I'm good. Thanks so much for asking, Harshitha. That's great for asking. So, how's your day?
It was great, sir. How was yours?
Great. That's good. It's good. Okay. So, okay, so okay. Could you please just give me a moment, Harshitha?
Okay, sir.
Sure. Thank you. Hmm. Just a minute. Okay. Okay, Harshitha. So let's do a question. I think we were doing the question as well, right?
Yes, sir.
Okay. Okay, Harshitha. So please try to solve this question, Acha. And this question would be Harshitha. In this question, the graphs points are given. You have to just basically point the graph points on each other, like in front of each other. Like if the time is 0, speed was 5. Time is 10, speed was 10. Just mark the 10 like that. Okay.
Okay, sir.
Try it. If not, we'll do it. Okay. Please try it.
Yes, sir. Yes, sir.
Yes,
So
Harshita.
for
So
the
please,
acceleration is negative 4 meter per second square.
no, Harshita, speed is increasing. It would not be negative.
So I
You
did
can just
30 minus 50
ah
divided by 5 minus 0.
30 minus 50 divided by
5 minus 0.
y.
So because to use y 2 minus
Harshita,
5.
you can just choose any two consecutive values. There is no need to choose like any random value. You can just any consecutive values. See this thing, 30 minus 25. You can take any value. It could be 10 minus 5. It could be 15 minus 5. You just have to need the two consecutive values to calculate the acceleration. Got it?
Okay, sir.
Okay, because we just need to as the question has already said it's uniform. That means in each interval the acceleration is gonna be same. It's not gonna change at all.
Okay, sir.
Clear? So 10 minus
Yes.
5 and the time change would be 20 minus 10. So it's gonna be 5 by 10. That means 4.5 meter per second square.
Okay, sir.
Okay. Please let me know the answer by the body. How much distance is covered the distance in the 50 seconds?
1500 meter.
1500 meter. No, Harshita. It is a trapezium, as I have said to you, that the distance measured is basically depends on the type of shape. Okay.
Okay, sir.
So if the type of shape is basically your trapezium, Harshita, see these things. Trapezium formula would be this is A. Let me just write it down. This is A. This is
Okay, sir.
B side of her, and this is your total is H. Okay, height of the trapezium. So height of the
Yes.
trapezium formula would be Harshita. A plus B, you have to add the parallel side of the trapezium and multiply with the height of the trapezium divided by the 2. Clear?
Okay,
This
sir.
is a very important
But,
question, Harshita. Yeah.
but in the graph, I
Hmm.
started that line from 0.
Why?
I didn't start it from 5.
Why? The question has already said at time equals to 0, Harshita, speed is 5. How did you take 0 the graph slope from 0? That's not correct.
Okay, sir.
Okay? It is basically at time equals to 0, the body is already moving. That means it has some initial velocity. That's 5.
Yes,
So
sir.
you cannot basically ignore this thing, Harshita. Okay?
Yes, sir.
Okay, that's great. Please note it. Let me know the answer for these two for this question basically.
Okay,
Time
sir.
is an hour. 1, 2, 3. This is 1, 2, 3 in is an hour. Okay.
Yes. Yes, sir.
Okay, Harshita. Do you let me know the answer for the first question?
So the first question I got 6.6 kilometer per hour.
6.6 velocity of the body. How did you get 6.6 kilometer per hour?
So I divided 40 and 6 for C.
Harshita, why?
So because velocity is displacement divided by time.
Harshita, this graph is velocity, already velocity time graph. Did you check the graph? This is not a displacement time graph.
Okay, sir.
Yeah, please do it again and let me know. Should I try to be a little bit more focused?
So it's 40 kilometer per hour.
Yep, that's right. Now it's correct. Next one. What is the acceleration from A to B?
So it's so I got it as 20 by 37 in fraction
When
form.
20 by 37. No, Harshita. How did you get 37 in the denominator?
So I did 20 minus 0 and 40 minus 3.
20 minus 0 and
40 minus 3.
Harshita, you are to. Don't know how did you get it. That's wrong, completely wrong, Harshita. You are mixing up all the things. Let me tell you. This was a straight question, Harshita. The question was asking that calculate the acceleration of A and B. That means this is your final velocity, this is your initial velocity. So final velocity minus initial velocity upon time. You are doing what? You are basically taking 20 minus 0. You are subtracting time in velocity, Harshita. That's not correct.
Okay, sir, but
Hmm.
why should we do that?
Harshita, acceleration is what? Let me know the formula of acceleration. Did you revise first of
Yes,
all?
sir.
Did you revise? Let me know. Did you revise before coming to the class?
Yes, sir.
Sure.
Yes, sir.
Graph portion, did you revise?
Yes, sir, I did.
But the kind of solution you are doing, it seems like you have not revised. Let
Sir,
me tell
but
you.
I'm a bit
The
confused in this.
question, Harshita, you are, let me tell you. Let me tell you. Acceleration is what? V minus u upon t. V is final, u is initial. What is the final velocity and in A and B?
Final is B.
B. So substitute final 40 over here. What is initial?
Initial is A.
A substitute over here. What is the time taken by
Yes.
the body from 0 to 40?
0, 0 to 40 is 3,
3.
3
So
seconds.
that means
3
change in time would be 3 minus 0. Substitute over there. So that's what we have done. You are taking time and velocity on on the numerator, initial time and initial time. Sorry, initial velocity, initial time, and in the new denominator, you are taking final velocity and final time. That's not correct, Rashita.
Okay, sir.
Please note it down and let me know the answer for the C part.
So it is 0 meter per second square.
That's wrong. That's wrong. It's okay. BC na? Okay, okay, sir. It's right. It's right. I thought
BC.
it's asking CD. It's right then. Calculate the CD part as well, Harshita. It's not mentioned over here, but I just wanted that you should calculate it. Let me know it.
Okay, sir.
Have you done the homework, Harshita?
Yes, sir, I did and submitted it.
अच्छा ठीक है. Last class one as well.
Yes, sir, I did.
ठीक है, ठीक है.
Sir, for C and D is a negative 6.67 kilometer per hour square.
It's 40 by no, Harshita.
So I did 0 minus 40 by 60. Sorry, 6.
Harshita, we have to take the time change. Why are you not getting this point, Vijay? You have to take the time change. I cannot just directly substitute the value of 6 into the formula. There are two values of time at which the body has started decreasing the speed and which the body has ended the velocity with 0. So you have to subtract this final time minus the initial time to get the actual time interval. That is 2 seconds. We have done the
Okay,
same thing over here, Vijay. 3 minus 0, it's gonna be 3 seconds.
okay, sir.
Got it?
Yes, sir.
Let me know the answer then finally of now.
Yes, sir. Sir, it's negative 20 kilometer per hour square.
Yes, Harshila, now it's correct. Got it? Now you got it? What mistakes you have made in this class, Vijay, in the questions?
Yes, sir.
Please, Harshita, try to be a little bit more focused while I'm giving the theory, Vijay. I know that you have the notes from the school, but the thing is, uh, you need to be a little bit more focused while understanding the theory, right?
Okay.
That's great. Okay. So I've given you the questions as well. Okay. So with this, like in the graph, okay, such type of numericals would come. Okay. Apart from these
Okay,
graphs,
sir.
nothing would more like no more types of numerical would come. Okay. So this is the type. If your school gives you the assignment, any worksheet related to the graph, you can send me out there and we'll basically discuss it. Okay.
Sure, sir.
That's great, Harshita. So, okay, next topic that we are going to study is Harshita. That is the last topic of this chapter. That is a uniform circular motion. Okay. So what it is uniform circular motion. Okay. Now let's talk about first of all what uniform circular motion is, Harshita.
Okay, sir.
Okay, Harshita, let's take an example. Suppose, like you must have seen that there is a thread, and you have basically attached a stone onto that thread. Yes or no? And when you are basically
Yes.
trying to revolve it, okay, so we'll see that, Harshita, the stone will move like this in the circular manner, isn't it? Yes or no, Bacha? It will move in a circular manner along the thread, so like this in this direction. Yes or no?
Yes, sir.
Yeah. So basically, Harshita, you can see this thing at okay, at every instance. See this thing. If the basically in this basically if the stone is moving in this direction, the direction for the stone at this point would be this. Okay, and at this point direction would be this. And if the stone is there, at this point direction would be this. And if the stone is there, at this point direction would be this, isn't it? You see this thing, Harshita. At every point, the direction of the stone is completely different, isn't it?
Yes, sir.
Right? But in this case, what happens basically, Harshita, we say that speed is equals to constant. So what do you mean by when the speed is constant, Harshita? What type of motion it is?
It is a uniform motion.
Uniform motion, right? That means, Harshita, it's a uniform motion. See this thing. Okay. So it says sorry. It's a uniform motion. And here, let's talk about the basically changes in the velocity case. Okay, Harshita. So our velocity depends on two things: speed and direction, isn't it, Harshita?
Yes, sir.
If your speed changes, acceleration will be there. And if your speed remain constant, but direction changing, then acceleration would be there, because velocity depends on two things, Harshita. If the speed is not changing but the direction is changing, that means there is a change in velocity that leads to the acceleration as well. Okay.
Okay, sir.
Okay, so that's why in this case, Harshita, at every point the direction of the stone is different. Okay, the stone is basically pointing in the different direction at every point. That means, Harshita, this is an accelerated motion. No need to write it right now. Everything is written. Just understand it properly. This is an accelerated motion. That's why it is called uniformly accelerated motion. Okay, Harshita?
Yes, sir.
This is your uniformly accelerated motion, because somebody asked that why even the speed is constant, but still this is called accelerated motion. The reason is, Harshita, direction keeps changing and hence the velocity changes. The change in velocity with respect to time leads to the acceleration. That's why it is called accelerated motion. Okay, Harshita?
Yes, sir.
That's great. Any doubt so far, Harshita?
No, sir.
Okay. So in this case, basically only the direction is getting changed, right, Harshita?
Yes, sir.
Okay, so let's take an example of the uniformly accelerated motion. You must have seen that Earth revolves around the sun in 365 days. Earth completes this revolution in 365 days, isn't it? So that means
Yes.
in every year, Earth moves with the same speed. But the direction of Earth keeps changing like this stone. That means, Harshita, the Earth is also doing an accelerated motion. Good.
Okay, sir.
Okay, let's take an example of the satellite. So satellite also basically revolves around the sun in the orbit of its, right? But still, maybe basically like every satellite has their own time period, like to complete one revolution. It depends. So it basically it completes that time period in the same amount of time. That means, Harshita, the speed is gonna be constant, but the direction is keep changing. That's why it is called uniformly accelerated circular motion. Okay, because this is a circular motion. I just forgot. It's a circular motion. Got it, Harshita?
Yes, sir.
Any doubt?
No, sir.
That's great, Harshita. Okay, so please note this down, Harshita. These are the things that is not present in your notes. I think so. So please note it down.
So you can continue teaching. I just took a screenshot of it. I'll write it
Harshita,
on.
sure, definitely you'll write it.
Yes, sir. I'll write it, sir.
Okay, as you were saying, you'll write it. Okay, no need to worry then. Okay, because next thing is basically, Harshita, the force. Basically, whenever there is an accelerated motion, Harshita, there is always a force involved in it to make the acceleration, right? That force in the
Yes.
where the body is moving in a circular direction, and hence at a uniform circular motion, that means a force would be there. That force is called centripetal force, Harshita. What it is called? Centripetal force. Whenever a body is moving, a centripetal force, whenever a body moving in a circular direction, a centripetal force would be acting on it. Okay,
Okay, sir.
that's great. And hence, see this thing, the direction of the centripetal force is always towards the raised radius of the circle. Clear?
Yes, sir.
And out.
No, sir.
That's great. Noted. After that, we'll just do the applications of the circular motion.
Sir, what happened?
Like you were writing something, I think.
No, sir, I wasn't writing.
Acha. Okay, I thought like you were writing. Okay, okay, no issues.
No, sir.
Okay, now let's talk about the examples of the uniform circular motion, Harshita. So artificial satellites also moves in the uniform circular motion around the Earth. Okay, this is one of the example. Next is move also around the sun in a uniform circular motion. Next is your
Okay.
Earth also surrounds the Sun in the uniform circular motion. And the last example is basically the tip of the second hand in the clock also completes the uniform circular motion because it completes the circular motion, the complete round or revolution in 60 seconds. That means speed is constant because that's at every minute, like in every minute, it's taking only 60 seconds. Okay, to complete one revolution. Okay, Harshita?
Yes, sir.
That's great. Okay. So now let's move to the speed of the uniform circular motion, Harshita. So Harshita, the body is moving in a circular motion. That means it is moving along the circumference of the body of the circle. So that's why it would be the distance traveled by the body would be 2 pi r. Okay. And the time taken is the time period by the body to cover one revolution or to complete the one revolution. That would be 2 pi r by t. Okay. Please just note it down this formula. After that, we'll move forward to the questions. Okay, this is the
Okay.
question. Please try, Harshita. Harshita, any answer?
Sir, I'm getting 5.5 meter per second.
Correct. Correct. Very correct.
Okay, sir.
That's right, Harshita. Okay. So with this, our chapter is completed. Now let's do one thing. Let's move to the NCRT exemplar. Just give me a second. Let me share my screen again. Okay. So we'll
Sir,
complete.
what about the textbook exercise?
Textbook, like NCRT exercise.
Yes, sir.
Harshita,
The book.
just a second. These are the same question that we have already done. I'll basically just a second. Let me just show it to you. We have done all the types of question. Now you should be practicing that same thing. Just give me a second.
Okay,
Let
sir.
me show it to you. Because Harshita, we have very limited amount of time. So what we have to do is basically, let me just show it to you one thing.
Okay, sir.
Yeah, sure. Here's this thing. This is the question I've given you as homework. Same question you have done in the class as homework as well. And this question we have done this thing as well. Okay. So basically, Harshita, is my screen visible? Just a second.
Sir,
Let me
it's
just show
not
it. Yeah, yeah,
visible.
yeah. I'm sure. I'm sharing my screen.
Okay, sir.
Okay. See this thing. Let me just show you one to you. So this question was given in the class homework. This question was given in the
Yes,
class homework. Okay. And
yes, sir.
and Harshita, these are the same question that like similar question. Harshita, basically see this signature. In class, we have very limited time. So we have to complete all the things along with the numerical. So I give you what basically I try to give you all the types of numerical that is that can be coming for your exam. So similar numericals can be done on your own. So if you want these
Sir.
questions as well to be done in the class, we can do it. That's not an issue. Okay.
Okay, sir.
So yeah, okay. Try to do this question, Harshita. Now this question is a little bit different. I know it will take a little bit calculative time to do it. Okay, the question is asking to calculate the speed. Okay, one more thing, Harshita. It's kilometer and in hour, so no need to convert it because kilometer per hour is a standard unit for such big calculations. You don't have to convert it into meter per second and all. Yeah.
Okay, sir. Yes, sir.